everybody, today is the last new topic in this unit. We're going to verify inverse functions by composition. So it'll combine the last 2 days of lessons. We learned about composite lessons 2 lessons ago, and last lesson was on inverse function, and this brings those two together. So if two functions f and g are inverses, then if you do f of g of x and if you do g of f of x, you will get x for their answers both times, and that only works when they're inverses. So we can use this as a check to see if two functions are in fact inverses of one another. And that's in addition to, being able to look at a graph and seeing if the two functions are reflected over y equals x, the line y equals x, and we can also check to see if two functions are inverses by looking to see if their points x and y are flipped. So this is just another way of doing an inverse check. So for starters, if I'm given these two functions here, I want to show analytically, that just means using pencil and paper, could also be rewritten with the word algebraically, that they are inverses of one another. So first I'm going to just do f of g of x. It doesn't matter which one you do first. F of g of x. So that means I'm going to replace what's in the parentheses here with what g of x is. So I'm going to find g of x first, get an answer, plug it into f of x. So this is going to say f of, replace g of x with what it is. So now the question reads, find f of x minus 3 over 4. So I'm going to go back to f of x. Wherever I see an x, which is just right here, I'm going to replace this x with this. So it's going to be 4 times replace x with this, and then plus 3 at the end. And what you can see here is the 4's knock out, and you're left with x minus 3 plus 3, and those knock out. So f of g of x equals x. Now we have to see, does g of, keep writing that, does g of f of x also equals x? Because if it does, it means that these two graphs are inverses of one another. So I'm going to replace f of x with what it is, 4x plus 3. So now the question reads, find g of 4x plus 3. That means go back to g of x. Wherever you see an x, which is just right there, replace it with 4x plus 3. So replace the x, then bring down that minus 3 all over 4. So you can see the 3's knock out, and we're left with 4x over 4. The 4's knock out, so we get x. So because f of g of x equals x, and because g of f of x equals x, then we can say therefore, those 3 little dots means therefore in math. Therefore, they're inverses. And that's that. Now you could also, again, take this equation, put in your calculator, and take this one and put in your calculator, and just look, are they reflected over the line y equals x? You can also look at a table like I did in the last video to see if, this has the point, 1 comma 2, this should have 2 comma 1, for example. So I'm going to do another one of these with you. Do another example here, just proving that these are inverses of one another. Feel free at this point, if you want to stop the video and just try it out on your own, go ahead and do that. So I'm trying to do the same directions here, prove they're inverses by using the composition of functions. So I'm going to replace g of x with what it is, the cube root of x plus 7. So now the question reads, find f of this. So go back to f of x, wherever I see an x, which is here. I'm going to use a parentheses here just because it's being raised to the power of 3. So I'm replacing x with the cube root of x plus 7 to the power of 3 minus 7. So I replace the x with the cube root of x plus 7 to the power of 3 and then minus 7. So it looks just like this equation here. I just replaced the x with the cube root of x plus 7. Well, you guys know that if I have an index of 3 and an exponent of 3, they knock each other out. So I'm left with x plus 7 minus 7. Those knock out. And we're left with x. So let's just make sure it works in the other direction now. So let's do g of f of x. And so if I do that, I'm going to replace f of x with what it is, which is x cubed minus 7. So now let's just go back to g of x. Wherever I see an x, which is just right here, it's helpful again to use parentheses sometimes. Replace it with x cubed minus 7. So it's the cube root of, replace the x with x cubed minus 7. Bring down that plus 7. Well, those knock out. You can see that right away. And you know that the cube root of x to the power of 3, those would knock out again, leaving you with x. Therefore, they're inverses. And again, if you wanted to also check, you could plug this and this into your y equals. Make sure they reflect over the line y equals x by verifying with the table that the points of this graph are switched on the points to this graph. So let me just do another type of example here. I actually ended off our last lesson with an example much like this one. In order to find the inverse of a function, we can do these steps over here, but keep in mind that there's only an inverse if a graph is 1 to 1. We also spoke of that in the last lesson. So 1 to 1 means it passes the vertical and horizontal line test. It means the x and y values do not repeat. So in looking at this example 4, we're going to follow these steps for finding the inverse of a function. First, we need to decide whether or not the equation defines a 1-to-1 function, because if it doesn't have, it's not a 1-to-1 function, then we can't find the inverse. And then if it is 1-to-1, we're going to find the equation of the inverse. So this is a line. I know it's an mx plus b form. We know a line with positive slope can pass a vertical and a horizontal line test. You could graph it in your calculator to verify as well that no x and y values repeat. So since I know it's 1-to-1, then I can go ahead and find its inverse. So first step here, replace f of x with a y, just because it's easier to work with than the f of x, because now we're going to switch x and y. And it's easier to switch an x and y than it is to switch an x and an f of x. So then we're going to solve for y. So I'm going to subtract over the 5 and divide by 2. And now, if we're finding the inverse, we should stick with the original notation that was given. We were using function notation to start. We should end with function notation. So I'm going to write the inverse of f of x. Remember, that's how that's said. You don't say -1. It's the inverse of f of x is equal to x minus 5 over 2. Or you could write this as 1/2 x minus 5/2, either or. And so now what I want to do is just validate that we have found the right inverse by using our new trick that we learned today, the composition trick. You could also validate by looking at this graph and this graph, and make sure they reflect over the line y equals x, and make sure the graph's table for this one is flip-flopped x and y values with this one. So if this is truly the inverse, then I should be able to find f of, let me rewrite that this way. The composition should be written this way. This will be true, it'll equal x. And then when I do the inverse of f of x, composed with the f of x, it'll also equal x. So I'm going to replace what's in the parenthesis here with the inverse. So it's going to say f of x minus 5 over 2. So now the question reads, find f of this. That means go back to f of x, wherever we see an x, which is right there. We're going to replace that x with the expression here. So 2 times replace the x with x minus 5 over 2 plus 5. And again, feel free to stop the video at any point to test yourself out. These 2's knock out. We're left with x minus 5 plus 5, gone, it's x. So now, again, if these are truly inverse of each other, then I should be able to do it the other way around. I'll be able to work over here. here and have enough space. So this should also equal x then. So I'm just gonna replace f of x with what it is, 2x minus 5. Let me move this over because I can tell it's not within my video screen. So now it's saying find the inverse of f of x at this. So go back to this equation right here where my finger is. Replace this x with 2x minus 5. So 2x minus 5. Oh, plus 5. I thought I had that wrong. Plus 5, plus 5. So 2x plus 5 minus 5 over 2. I was looking ahead and realizing that wasn't going to cancel if it wasn't the opposite sign. So these knock out, and 2x over 2 knocks out to give you x. Therefore, I know I did this correctly. I know that my inverse equation here is definitely the inverse of this because the composition of functions rule that we just talked about today works out. A slightly different example down here. Let me just slide this up. If I'm using the same directions that are in bold right here, I would not even start this problem because I cannot begin to find an inverse because this function is not one-to-one. I can see that this is a parabola that smiles at me, and it is 2 units up from the origin because that's a vertical shift. So because it's not a one-to-one function, it cannot have an inverse, so I wouldn't even proceed with that problem. So that's it for today's lesson. The homework that you could work on tomorrow would be this one right here, day 12. Keep in mind that I changed the test date because many of you have some APs going on this week and next week, so I will not post any more videos. If you have any review questions, you can email me throughout the week. I will post your test next week Thursday, excuse me. It'll be due next week Friday. Have a good one. Good luck if you're taking APs.